但是我们总水那所以你稍微不用找作业。刚才没听那个。操作，不能让它打开这样很自动量。
别人搞操作，我下次教那些美国脾气会不会
说打字
你数学1个月10遍，
你教授上
求让放片子。
那同一课应该很行。
我这里是个华人高中一样，在线不意思这个思维。
是条不是？
不是配的那个干什么？
那个不是5点的，正好3楼电梯口。是跟他搞好关系。我估计是我早就记了，现在还没有。4个其实没说完。
Is there anybody whose email I don't have who doesn't have access to Piazza yet?
不想明白。
Hasn't been getting announcements from me?
他平他妈那个，别，我平时在。
Okay, let's go ahead and get started. Let's see, a couple things just in terms of events that I've mentioned. So we'll have a session just after class today in Evans 342. Totally optional, but if you're interested in getting some more help with the basic Unix stuff that's in that Unix tutorial, or if you're having any software installation problems, or if you have an SCF account and you're having problems accessing any of the SCF computers, then come by. I'll be there. Presumably there'll be a few of you there, and if you want to, you can work together on the Unix tutorial with me there to answer questions as you work through it. So that's totally optional, but please attend if you think it would be helpful. I'm going to circulate a little sheet that tries to find a time for the R help session that we'll hold on either Tuesday or Wednesday evening next week. Only fill this out if you're interested in attending. If you're not going to come, then don't bother to say what's a good time for you, obviously. So that got more laughs than I thought it was going to. I didn't even mean to do that. Okay, so, and if you're interested in attending, then mark down a little X for yourself if you can't attend a given one of the sessions. So I'm going to try and find which of these has the fewest X's next to it. Yes, questions?
What will the R, like what will that cover?
Okay, good question. So the plan for that is Andrew, the GSI, who none of you have met yet because he's not yet in town or not yet back in town. He'll be basically, I think, be going through in some form those first 6 modules or so of the R bootcamp. So there'll be an opportunity for you guys to work together in pairs or in groups. You can ask him questions. He might present a little bit of stuff just to sort of accentuate, what word am I looking for? Just to reinforce some particular points or topics, but it'll probably be a lot of just sort of group work and working through things there with him able to answer questions. Okay, the other thing I'm going to circulate, which is of similar ilk to the R help session scheduler, is I'm trying to find times for office hours that most people can attend. So put down a little X in the block of a time if you can't attend, if you have a class conflict or something like that for any given one of these blocks. So just to be clear about this, at the end of the period, I'm expecting this to have lots of little X's in all of these various different boxes, depending on when you can't attend. So I'll circulate that from 2 different directions. Okay. So any questions from last time, either logistical or any of the Unix content that anybody wanted to ask me about? Okay. All right, so let's, we're basically done with the first unit. Let me just say I'll just do a very brief Git demo just to sort of start getting people up to speed. And then we'll switch over to the bash unit. And actually, I'm just remembering I did want to say something about the survey. So essentially, all of you filled out the survey. Thank you for doing that. And going back to the R help session, many of you are in the 3 to 4 category in terms of your R experience. So if you're in the 1 to 2 category, you're going to need to do a fair amount of work over the next week or week and a half to get up to speed. As of, say, the end of next week, we're going to jump right into doing things like web scraping, where we're going to be using R lists and other data structures, getting data into these data structures, looking into the depths of the data structures, using lapply and things like that to do manipulations. So if all of that sounds intimidating, then you should be doing some work to get ready to make sure you're getting up to speed in R. If you're in the 3 category, I would say, think a little bit about whether you want to get some extra practice or if you feel reasonably comfortable with the things in the modules in the boot camp, and decide based on that how much more work you need to do and whether or not to come to the R help session. Okay, I'll just show you a little bit about what people's experience with Unix and with Git are. So many of you are in the categories of sort of 1 to 3 of either no or sort of modest amounts of experience with Unix. So the goal, of course, of the next couple of classes is to get people up to speed there. If you're in this category here, then you already know a fair amount about using the Unix shell. I don't know how many of you decide to come today. If you are in that category, you might be skipping it. But if you are here and you're in that category, please just jump in with comments as I'm talking. If you have a different way of doing something that I'm doing, I'd love to hear that. I might learn something, and the rest of us here will learn something from you. So please chime in. And then in terms of Git, sort of a similar story that many of you have no to modest experience. There are a few of you who have a lot of experience. Those of you who have a lot of experience, lend your expertise as we're doing things in section and whatnot. Okay, so back to the unit. Okay, so I'm going to go back to a terminal here. What I've done at the moment is I'm currently on my Mac here. For example, if I say echo hostname, this says well, I guess that doesn't really distinguish the fact that I'm on my Mac, but I am. And here I'm on my desktop that's in Evans. Okay, so I've got a view on 2 different machines going in these 2 different windows here. So if you're first trying to download and get the material from a Git repository, then you would be doing, if you're going to do this from the command line, you would be doing something like this. So generally these are going to be github.com. There are other Git hosting services like Bitbucket, but a lot of people use GitHub. Okay, so this is the name of the repository. And I'll point out that this is how I would do it from the command line. You can use sort of different variations of this git clone command. This particular variation will work. You can also clone a repository from various Git graphical interfaces, and you're welcome to do that. Some of what we're going to do in class when I'm asking you to do things at the command line and save your work in code files, I will explicitly be wanting you to actually write it out as code that you can save in a file. In other cases, it's fine to do things by pointing and clicking. But if you're pointing and clicking, of course, it's hard to describe to somebody else what you did to point and click to get to some particular result, right? The easiest thing to do is you have a code file that explicitly replicates what you did, and then you can give that to somebody else, and they can execute that code, and then they can carry out exactly what you've carried out. So that's part of the goal of talking a lot about scripting in the class in general, in these first few classes, and doing things like this that we could do in a graphical interface, but doing them from the command line. Okay, so I'm cloning this or downloading the material from the repository and making a local copy on my laptop here. Hopefully the wireless will not be too flaky, and I'll actually be able to get that to complete. Okay, there we go. So now if I say ls stat243 and with tab completion complete that long set of characters, that should show me that I've got all of the materials that you guys have been downloading. So for any of the tutorials of the class material, you can download it like this rather than having to download the zip file from the graphical interface and then unzip it and carry on like that. Once you've downloaded it once, what you'll generally want to do to make sure you've got the updated materials from me as I'm adding material to and correcting material in the repository is Git Pull. So just as an example, here I am on my desktop. I have a copy of the Git repository on my desktop as well. It happens to be in this particular set of subdirectories within my SCF Statistics Department home directory. So I'm going to go in and I'm just going to make a small change to one of these files. Okay, so I'm going to add, I don't know, what should I do here? This repository holds all the course materials for fall. Okay. At the University of California, Berkeley. Okay, so now I'm going to save that. And now if I do git status, it will tell me that I just modified this README file. And it says that these changes are not staged for commit. So what this means is I modified the file, but I haven't told Git that I wanted to keep a record that I've made these changes and sort of update that file in Git's view of this particular set of materials in a repository. So at this point, I would do something like git commit -am. Let me make this a little wider so it's not quite so awkward there. Git commit -am, and then I would add a little text message that is just basically says, what are the changes that were made in this particular commit? So I'm updating the repository, and I want to say, I want to summarize for myself so that when I look back in the future, when I look back, I have some idea of what the changes were made at this particular stage of changing the repository. So I'm going to say updated the README file. Okay, and now if I do git status, what you'll see is that your branch is ahead of origin master by one commit. So what this means, so origin master is the version of this repository that's in the cloud on GitHub. And so that's saying basically that what I have on this particular machine is one step ahead of what is currently in the cloud. Okay, so that means it's sitting on my machine, but the changes have not propagated to any other places where this repository is located. So if I do git push, then that's going to go ahead and push those changes, take the changes, and put them up onto github.com into the cloud, and it gives you some information that says that that's what it's doing. We'll talk about branches a little bit maybe on Monday and then further on later in the class, but you can have different versions of a given repository existing at once, and those are called branches. At the moment, there's only one branch in this repository, and it's called master, and when it says master goes to master, what this means is it's taking the version of master that is on my desktop where I just made the changes, and pushing those changes to the master branch that is up in GitHub. So that's why the name master is repeated. Okay, so now if I do git log, what we'll see is this is a record of various changes I've made, and you can see I just made this change to the README file today, 2 minutes ago. Andrew, the GSI, made some changes yesterday, and so on and so forth. And this just goes back down the history of the of the changes that have been made. I can hit Q to get out of this, I think. Yep. Okay, so we're going to see a bunch of this on Monday and further along during the class. Questions about any of what I've done here? Okay, so now if I want to get those changes onto this laptop, then that's just a one-step process of saying Git Pull, and it should, well, before we do that, let's just check and see what the README file looks like. Actually, I need to go into the repository. I need to go into the directory in which the repository exists. And now if I say less, which is just a Unix command that's going to basically page through the contents of this file, you can see that it's still the old UC Berkeley version of the README file. In contrast, if I say Git Pull, then it's going to say, okay, now I'm downloading all the materials, and it says there's been a change made to the README file, and that's the only file that changed. And once I've done this Git Pull, now if I do arrow up to recover my previous commands, and I hit return at this point, you can see the change has now been recorded, and now I have the updated version of the README file. So in addition to sharing material between you and somebody else, this is a very nice way to share material between different machines that you have access to without having to do a lot of tedious, like, which machine has the most updated stuff, and did I copy it to that machine, and all of that to sort of get everything in sync. All you need to do is push the changes up on one machine, and then do Git Pull on the other machine, or other machines. Okay. Questions at this point? Yes, in the back.
Is there any way either at the end or before classes you should have like log of the code you're going to use? Because if you type it and then it prints and knows what you just wrote.
So I can think about whether there's a good automated way to do that. I am doing a screencast, so you could go when I post the screencast, you could go there and you could go back and see what I wrote. But that's a good question. I'll think about whether there's an easy way to do that or not. Okay, there's another question over here. Yes.
What if you make a change as well prior to pulling?
Yeah. So in that case, what will happen is there might be multiple changes made in a file. If the changes are made to different lines in the file, then you can then generally Git will handle merging the different versions of the file together in an automated fashion. If you on two different machines, or you and me, make the change to a file on the same line, then there's going to be what's called a merge conflict, and one of us is going to have to resolve that conflict and decide what should be the version of that line. So we'll get more into that when we start talking more about Git. We probably won't talk about it too much on Monday, but we'll talk about it later on during the course of the semester. Yes?
This is similar vein, but are we going to talk more about version control and for specifically accessing previous versions? Like
Accessing previous versions of the repository?
Yeah.
Yeah, I'll illustrate that very quickly here, but we will talk more about it. So if I do git log here, suppose that I wanted to get back to the version of the repository before I changed the README. Suppose that I hadn't changed the README, but what I'd really done was I'd gone in and done a whole bunch of stuff to the code, and I realized, oh, that was a really bad idea. I introduced a whole bunch of bugs into the code, and I just did a really lousy job. Maybe I was sleep deprived, maybe I'm just not a very good coder, who knows. So I can do something like, if I take at least of the first few characters of the name of this commit, and I just copy those, I can do git checkout, and then paste in the characters. So you don't need to paste in the entire thing, because this is enough to uniquely identify that particular version. And so if I do git checkout it'll give you sort of a whole bunch of information here that we can ignore for the moment, this whole detached head state and things like that. But basically at this point, if I now do less on the README file, you can see that is indeed the old version of the file. And there are various ways to basically wipe out that commit and basically reset things so the previous commit is considered to be the current version of the repository. And we'll see more of that. Yeah. Okay, other questions? Okay, so I don't want to say more about Git here. We're going to see that on Monday. We're going to see it in various sections during the course of the semester. But I did want to do a little bit to get people sort of prepared for Monday. Okay, so the idea now is we're going to work our way through a demo of using the bash shell. And the goal here is to sort of do what happens when kids learn how to learn a language. I want to sort of just sort of throw a bunch of stuff at you, have you see how it might be useful, and see some of the syntax and how I might use it. And then either you've already done a little bit of this, or I'm asking you to do this by Monday afternoon. Then you'll go into the bash tutorial and you'll actually see it written out more formally, what all the different commands are, and sort of what the sort of a manual to how you would do this sort of stuff. But I think it's hopefully probably going to be useful to sort of see me doing some live demonstrations and illustrate sort of what you can do before you get into the tedium of like, what are all the different commands and what are the different options and things like that. So that's the goal for today. And then you'll get a chance to practice some more with trying to solve various problems using the shell in class on Monday and Wednesday, and then the first problem set will have a couple problems on doing this as well. Okay, so the other thing I'll mention here is that what we're going to talk about in the examples and what is in the bash tutorial is my view on what is going to be most useful to you going forward in your careers. So the Unix shell, the bash shell, the particular shell that we're going to use, which is the bash shell, has a ton of things you can do with it. You can write entire programs that will do very sophisticated things just using shell programming or shell scripting. I'm just trying to highlight the things that I think are going to be most useful. Generally, they're going to be sort of 1 or 2 liners. You're not going to be writing a big program in the shell, although you could if you really wanted to. So that's sort of a little bit of backdrop of how I'm thinking about this particular unit. Oh, and I guess the other thing I'll comment is if you start to be writing very much longer shell programs, it's very likely you might want to move to Python and do the same function. You do the same sort of thing in Python because it's often a little bit easier in terms of syntax to do it in Python. But the shell is really useful for sort of doing operations very quickly, sort of just one-off kinds of operations, and automating things that that would be tedious to do otherwise. Okay, a couple other comments about the shell. And the principles I'm about to mention are basically hold for when we're thinking about programming more generally, but they're particularly well, I think, exemplified in using shell commands, which is the idea of these different shell commands. And we've already seen some of them. We've seen things like less and cd and pwd and various other things. The goal of the developers of those commands was basically to write a command that did one very specific thing very, very well. And then the idea of what we're going to be seeing next is that you can compose very sophisticated operations by combining commands in particular ways. And the shell is set up that you can very easily pass output from one command as the input to another command. So what we're going to see is basically that we're going to do things by using lots and lots of specific commands to piece together a much more complicated workflow or set of operations. So the two sort of adjectives I'll use to describe that are modular. Each function should do a very specific thing very well and not try and do too much. And then composable, that we can combine these things to do much more sophisticated tasks. Now, if you're writing R code or Python code with that sort of those principles in mind, then you're probably going to do a pretty good job writing code in other languages as well. So just to comment on that. Okay, the other thing is the technology we're using here is old. Right, the shell programming was basically developed, I don't know exactly, but somewhere in like the 70s and 80s. So this is decades old. It is still heavily used today, and that's because it was done really, really well. All of these commands operate really quickly. They're well designed. They have a lot of functionality to them. And so we can thank the computer scientists and the programmers who were working in the 70s and 80s for putting all this together. And the fact that people are still using it today indicates the success of what they did. Okay, so all right, so let's go back to let's look at the bash unit. Okay, so I am going to go through a series of what I'm calling missions here, and these are things that I decided I wanted to illustrate things that we could do. So the first one is that we're going to look at this file called coop.txt, which is in the repository. I'm probably going to use an older version of the repository that has more files in it, just because we can do a few more things with that. So I'll probably use the version of the repository from 2 years ago. And what I want to do is this coop.txt file has basically information on a whole bunch of weather stations from across the United States. So each row is a weather station. And it tells where the weather station is and what state it's in and a whole bunch of other information. So the idea of this challenge is to try and figure out how many different weather stations there are in the various different states in the US, to try and summarize some information about the weather stations. And the idea is that you might have been given this file or downloaded this file off the internet, and instead of having to pull that into R or Python and do a whole bunch of R and Python coding, we can very easily from the command line just do a few simple operations and get a sense of what the data set looks like. Okay, so I think what I want to do here is try and get the text editor and the trying to remember how to get these windows. Okay, so let's do that. Okay, so I want to be able to save my code here on the right side and be copying and pasting back and forth into the shell. Okay, so I'm going to go to my home directory with just CD. I'm going to go into the desktop, and then I'm going to go to okay, so I want to actually get the version of the repository from a couple years ago. So let me go back up to when I cloned the 2017 repository, change that to the 2015 repository, and now download that material. Okay, so now I'm going to, okay, come on, Air Bears. Okay, so now I want to, once that finishes, which is taking longer than I would like, I'm going to then go into the data repository. Oh, you've got to be kidding me. Okay, there we go. Okay, so here I am. If I do ls and if I do ls-l to see the long format, we can see that there's this coop.text.gz, so it's a gzip version of the file. It's about 2 megabytes zipped, so it's going to be moderately big when we unzip it. If I unzip that file with gunzip, so this is a sort of Unix-specific version of zipping a file, and now we do ls-l, we can see that coop.text is about a 20 megabyte file. And if we want to start to get an idea of what that file looks like, let's do less, and we'll get to page our way through the file. So I think we saw this last time. If I hit space, I'll get the next page of output from the file, and I can use the up arrow and the down arrow. But we can already start to get a sense of what this looks like. It looks like it's got these particular field names, and we can see it's got Alabama. Those are the initial weather stations that are listed, are all in Alabama. These are probably the city names or some sort of local identifying information. All right, does this look like a delimited file? Like often we'd see a comma delimited file and the fields would be separated by commas. We can just look quickly here and see that doesn't seem to be the case. And in fact, this doesn't even look like the fields are necessarily separated by a space in, like, you know, there's one space between fields. It looks like what it is there's what's called a fixed width format. So every field is a fixed number of characters. So it looks like this first field, which is the co-op number, looks like it's about 3 characters, and then there's a space, and then whatever this WDAN is, it looks like it's maybe 2 characters, and so on and so forth. So in fact, it looks like this WMO, FAA, NWS, it looks like some of those fields are actually missing from here because it looks like there's a lot of white space here. Okay, so now let's take our first challenge to be, how would I go about grabbing the state information from this file? So I just want to take the 2 characters representing the state here. So I need to figure out what characters they are in this fixed width format if I'm going to be able to grab those. And the first verb, this first sort of function or command that we're going to use to start to pull out individual columns is the cut command. So cut is really nice because it basically allows you to split up text files into fields or columns. And oftentimes you'll use it to split up a file based on commas being between the fields. But it can also handle this fixed width format with a different flag. And so I happen to know, but if all I told you was that the cut command was really useful for splitting up files by field, then the natural first thing for you to do would be say man cut. And then if you want to, you can then page down and try and get a sense of what it does and what flags would be useful to you. You very quickly see that you could use -d to specify a delimiter, like a comma, by which to split up the fields. And if you were able to sort of interpret what this -d means, you might realize that this would allow you to split up based on the number of characters in each of the rows. So that's actually what we're going to use here. Or if I told you that the -d flag was particularly useful, if you hit a / and then do -d, that will search for the -d wherever -d occurs in this file instead of you having to page all the way through the help information. So I can hit N to go to the next occurrence, and this allows me to very quickly search through this help file to find the particular flags that are of interest to me. Okay, so I happen to know that -b does something like of what I want. So I could do something like this here. I can say cut -b 5077, and then the name of the file. And so let's not think about the less yet. But this is basically going to pull out the 50 through the 70th characters in every row from this file. And I'm guessing 50th through 70th because when I looked at that, I just sort of guessed that maybe the state information was roughly in that position in each of the rows. And so if I do that, and then the argument, so I'm giving this flag or option to the cut command, and this is the argument that is being passed into the cut command. And if I do man cut, what we'll see is that the argument that you can pass in optionally is the name of a file, and that's the argument that I'm going to pass in. So let me pause. Questions so far? Okay, so if we do that, you can see it's just scrolling through and printing all that information out to the screen. Now we're going to start to see this idea of composability of operations. I could do that, and instead of just printing it out to the screen, I could pass it into the less function. So we already saw less at one point, and we did something like less. We did less co-op.text. So that was using less, where the input to less was given as a file name. Instead, what I'm doing here is I'm passing the output of the cut command into less. And the reason that this works is that less and many other of these Unix commands can either take the name of a file as the input, or they can take what's called standard input as input. So that's abbreviated as stdin. And so by default, if I just did this, that the output of that is called standard output, and it will generally just be output to your screen. But what this piping symbol does is it says take the standard output from this command and pass it as the standard input to this command. And so less can either take a file name or less can take standard input, and in this case it's taking standard input by virtue of this pipe that the output of this command is being passed in as the input of that command. Questions about that? Okay, so if we do that, now we can see the output and page through it and be able to get a better sense for it. And if I were to now at this point just sort of count off characters or start guessing a little bit more, and finally I figure out that those are the 60th and the 61st characters in each of the lines. And so at this point I could now change what I had done here and change that to the 60th and 61st. Hit tab complete to finish the file name and see if I got it right. Yep, it looks like I got it right. So it looks like I got the two characters that I'm particularly interested in. And now at this point I might want to know what are the states that are represented in this particular data set. Do I have weather stations from all 50 states in the United States, or is this only the weather stations from some of the states in the United States? So now I can start to combine even more of these operations in this modular fashion where I'm piping the output from one command as the input to another command, piping the output from that second command as the input to a third command, and I can just continue in that vein here. So that's what I'm going to do here. I'm going to go ahead and sort the output of co-op of the state information from having run that cut command. And if I do that, what you see is it sorts it, and it goes probably from Alabama all the way down to Wyoming here. Now that's not particularly helpful because I've got all these repetitions, right? So if I want to get rid of the repetitions just to see what the unique state names are, then there's a command called unique. And if I do that, now I can see what the different states that are represented are here. Okay. So you can see it looks like there's some missing state information. That's that first line. Looks like most of the rest of the, maybe all of the rest of the US states are represented. We might see if there are some that are not states that are represented here. There probably are. We could do things like pass that into NL, which stands for number of the lines. And so if I do that, what we can see is it actually says that there are 62 unique different values in that field. So that indicates that we've got weather stations for more than just the 50 states, and we're starting to get a little bit more of a sense of sort of what the nature of the information in this file is. Oftentimes you're going to see this pattern of using sort and then unique, because in order to use the unique function or command, you first need to have it sorted, because it's basically just going to strip out lines that match the previous line, and it's only really going to work effectively if you've got them already sorted. Okay, another thing we could have done, and this goes back to this idea that each of these commands has lots of different options that we could use. You're not necessarily going to know what they are unless you either Google something on the internet, look at the man page. If I tell you it, if you see somebody else's code and use that as a demonstration of things that you can do. But there's a C command, a -C flag to unique, and that will actually, well, we'll see what it does. That will actually count the number of occurrences of each of the unique values. So you can already see this is quite powerful. You know, if we had wanted to do that in R, we would have had to read the file into R and then we'd have to run some commands on it to basically do a tabulation of the different occurrences of the different states. I was able to do that here just at the command line with typing about 70 characters. Right? And so I can already see that, you know, what the distribution of the weather stations is. You know, there are quite a few in Colorado, not so many in Connecticut. We could see if it seems like there are some that are missing. We can see that there are some that are sort of outside the contiguous US. So this is probably from Guam, which has obviously been in the news a lot in the last few weeks. Okay. All right, so this is we've already now combined a few different commands here, passing the output from one as the input from the other to do a fairly sophisticated task. Questions before I go on to the next one? Okay. All right, I'm going to hit Control A, Control K deletes the line. Okay, so let's go back and look and see what our next mission is. So the next mission is that suppose I have some big input text file that actually is comma delimited, unlike that previous file. So now suppose that every field is separated by a comma. And I want to get a sense for how many different fields are there in each of the rows in that file. So I want to get a sense of how many, you know, maybe this is a data set that I could use as predictors in a regression model or something like that. I just want to quickly get a count of how many different fields there are in the file. Of course, I could read it into R and then count the number of columns. I could open it up in Excel and look and see what the number of columns are. But this is a way that I could do it in a very automated fashion. So again, I'm going to copy the code into my editing window and then move over to the terminal here. Okay, so if I look at this CPDS file, it's a file that has a whole bunch of economic data for various different countries in the world. So something about GDP, unemployment, outlays are probably government spending, something like that. And you can see that each of these fields in this case looks like they are comma separated or comma delimited. So one way to think about counting the commas here might be, well, let me just pull out a single line from here. And let me just try and strip out the commas and count the number of commas that I strip out from one of the individual lines. So that's the strategy that I'm taking here. There's probably, in general, in the things that we're doing here, there are going to be lots of different strategies to do different things. And so you might have a different idea of how you would do it. You might have a better idea than how I did it, where the code is sort of easier to read and easier to understand. Okay, so what I'm going to do is I'm going to say tail -1 and then the name of the file. So tail and head are sort of flips of each other. Tail will give you the last few lines of the file. Head will give you the first few lines of the file. But you can also basically tell it that you want it to start a few lines down or start a few lines up. And so you basically can sort of more or less get anywhere into a file from the bottom or top of the file if you use the right flags, either with head or with tail. So in this case, I'm going to do tail minus n1. And that's going to give me this particular line from the file. Now if we look at the CPDS file, and if we page through it, what we'd see when we got to the end was that should be the last line of the file. So I'm just choosing that as an individual line where I want to be able to count the commas in that line. Okay, so if I do, now I'm going to start to use a function called Grep that you're going to use a lot. It basically looks for particular characters or sequences of characters or patterns either in files or in standard input that's getting passed into Grep. So Grep is like less. It can either operate on the lines of a file or it can operate on the lines of the input that is being passed to it as the output from some other command. And essentially all of these commands that we're going to look at operate line by line. In some cases, they'll sort of give you a piece of output that's relevant for the entire file, but often they're going through and giving you information. They're doing something on every line of the file. Oh, side comment here. Another thing that I'll mention is one of the reasons, there are two reasons at the moment, there are others, but there are two reasons at the moment that are top in my mind of why it's really nice to work with text files as opposed to binary formats or formats like Microsoft Word that are proprietary to a particular company. One of those is that when you use text files with Git, Git can work with text files very easily because basically all the changes are made line by line, and instead of having to save a whole new copy of the file when you change one line, it saves the old copy of the file and it saves the change to that single line that you made, and so it can work very efficiently with text files. The other reason that it's nice to have text files is we can do all of what we've just been doing in Unix and operate on text files very efficiently. So those are reasons that working with text files is quite nice. So I'm going to pass this into Grep, and I'm going to look for commas in that output. Now, if I were using Grep with a file, I wouldn't have any of this. I would just have Grep, and I would be saying, look for commas in the name of a particular, in a file, where I indicate the file name here. But in this case, I'm again using Grep like I did with less, where I'm taking the output of this command, piping it into Grep, and Grep will understand that it should take input in this case as the it should take its input as the output of what's getting piped into it. So if I do that, it's not really very helpful because what Grep does is it basically identifies whether the line contains a comma. Well, in this case, I'm only passing it one line, and of course it contains a comma because we've already sort of determined that, right? So I have to figure out, is there some way that Grep will actually just print out only the commas? I happen to know that there is, and I happen to know what the flag is, and we'll see it in a second. But if you didn't know that, then the way that I tend to operate is if there's a Unix command that I guess might do what I want it to do if I change a flag, it's almost always the case that I can find a flag that will do the thing that I want it to do. So if you know that Grep sort of picks out and identifies characters that you want to identify, you might guess that with a particular flag, it might just return the matches and not return the entire line. And so that, if you look in the help, or if somebody just told you, like I'm telling you now, that is what the -O flag will do. So I'm going to do tail -n1 grep -O, and if we do that, we can see it's now printed out just the commas here. Okay, so I'm getting closer, right? I've identified just the commas, and now what do I need to do to figure out how many fields there are in this data set? I just need to count them somehow, right? Okay, so what might I use? Have we seen it yet? So I think we saw word count, the WC command. So we might think about doing this, word count. And that says, okay, what this is really saying is there are 5 characters and 5 lines, and I'm not quite sure what the 10 is. Maybe yeah, we'd have to look at the documentation to see exactly what this is. But if I want to count the number of lines, I can pass the -l flag, and that'll just return the 5 without all the extra, the multiple pieces of information there. So, okay, so I'm getting close to being done with this particular task, right? I could just, and if I wanted to save that and operate on and use that resulting information later on, then I could do something like this. So this is now, we already know what this is going to produce. That's going to produce a 5. If I want to save that result as a variable that I can then use later, just like in R I save and name variables, or in Python or in any other language, I can create variables in the shell, and then I can use those variables later on. In this case, the syntax looks like this. You name the variable, you say set it equal to, and then I could say n fields equals 5 if I were just hard coding in the 5. But in this case, what I'm doing here with this $sign in the parentheses is I'm saying, take the result of this command and treat it as a variable that I can then put into this particular, into a variable named n fields. And one critical thing that you'll see if you try and type this in with spaces here is that the shell will get very confused. You can't have any spaces between the name of the variable, the equals, and the thing that you're trying to put into the variable here. Okay, so if I hit enter, it doesn't show me anything because the result is actually filling in the variable. But if I then want to know what the value of that variable is, then I can do something like this. You'll notice that there was no $sign over here, so when I define a variable, I don't use a $sign. But when I want to reference a variable later on, I need to use a $sign. And it's reasonably good practice to put the squiggly brackets around it to say this is the beginning and end of this variable name. I could do something like this. N fields. Well, let me just do the simple thing first. So if I say echo n fields, it says indeed 5 is stored in that variable. If I do something like this, it can concatenate the information from the variable with the additional characters that I have here. So you can basically paste together strings just by sort of doing it directly. Or I might have tried to do something like this. And this illustrates why I wouldn't want to, why I might want to use the squiggly brackets, because if I do this, it says it's looking now for a variable named nfields foo. It's looking for this to be the entire name of the variable, and it doesn't find it because I haven't defined that variable. So there's nothing in there, and hence it just prints out an empty line there. But if I just had n fields, this would also work equivalently. Okay, questions? Yes.
How do you check all those variables?
How do I check all of them?
Yeah, I mean, like how?
Yeah, that's a good question. I'm not actually sure if there's a way to see all of the variables that are defined. One thing that you can do is type env, and this will show you all of what are called the environment variables, which are sort of variables that tell you something about the particular session that you're in. So that can be quite useful. I don't know why that got darker. All right, sorry about that. I'm not sure what's going on with the projector. Okay. Other questions? Okay, so if I look at this CPDS data set, what's wrong with the answer 5? How many fields are there actually here? There are 6, right? I counted the commas, but the commas only occur between the fields, right? Okay, so what could I do to deal with that? Okay, so I could try and do the actual arithmetic somehow in the shell, right? And again, we're trying to do everything by typing in commands. We're going to try not to do anything manually. So I could try and figure out a way to do the calculation in the shell. Any other ideas of what I could do to try and get 6 back instead? What if I had another comma at the end there? Right? If I had a comma at the end here, and then I counted, I would have 6. So another possibility is I might actually put a comma in and then count it. Right? So you can sort of think about different clever ways to try and solve problems, and that's when I'm putting together these different things in the shell. That's basically what I'm trying to do. Is I'm trying to think about what are the ways that I can solve my problem with the least amount of work that would address the problem. So in this case, there is a way to do this with a little program called BC, which does calculations. It's a little bit awkward, I would say, but it will work. So if I've already created n fields and it's 5, I can then change n fields to be 6 by saying take n fields and add 1 to it, and this is just a character string, and in order to use the BC, I have to echo that into the BC command. So it's a little bit convoluted, but it will work, and that will produce a 6 as n fields. So now if we do echo n fields, that's now 6. What about if I wanted to do it the other way? What if I wanted to add a comma in? Well, I could probably do something like the following. I could probably do something like this. And now I'm going to take the output and put it into a file. So I'm going to put it into a temporary file that I'm just going to call foo. Okay. So if I do cat of temp foo, that's got my 5 commas in it, right? And now if I do echo comma into temp foo, I'm going to add another comma into foo. What the difference between if I use 2 arrows here, or 2 greater thans, then it's just going to add stuff onto the end. If I only used 1, I would overwrite this file and I'd just have a single comma in there. So in this case, I want to add a comma onto the end of the existing file, so I have to use the double greater sign. And now if I do cat temp foo, now I've got 6 commas in there. Now I could use the WC on that, and I'll correctly get that there are 6 values, and that therefore there are 6 fields.
What was cat?
So cat just basically takes all of the information in the file and just prints it out to the screen, no matter how much there is. So if you've got a file that has 10,000 lines, it's going to print them all out, and it's not going to be all that helpful to you probably. If you have a file with 6 lines, then it's handy to just look at it.
So how about less?
And then, yeah, so less, if you've got a file that's more than it's going to fill up your screen, you generally want to use less, because then you can page through the file page by page instead of just printing it all out to the screen at once. Okay, so did anybody not get a chance to fill out that form? If you're interested in the R session next week, did anybody not get a chance to fill out that form of what times are good for you? That should be circulating. And if anybody didn't get a chance to fill out the office hour form of what times don't work for you, I'm going to get those forms and I'll just have them up here for the next couple minutes, so come up and fill that. So, anybody who's interested in the optional help session, I'll see you in a few minutes in Evans. Otherwise, I'll see you in class on Monday. And remember, you have an assignment on Monday to turn in the answers to the first 10 questions from the bash shell tutorial.